Hello, I'm here to teach you how to solve a related rates problem involving a triangular trough. So here's the problem. A triangular trough is 3.6 meters long, 1.2 meters deep, and 0.9 meters wide as shown in the figure. And this is the figure that I've wrote. It is being filled with water at the rate of 2 cubic meters per second. How fast is the water level rising when it is 0.6 meters deep? So everything is being filled here. That's the data that we have. The height, the length, the width. What we need to do now is write the given. The given first is we have a change in the volume. It says here that it is changed at the rate of 2 cubic meters per second. So it's the volume, and then we write with respect to time, and becomes 2 cubic meters per second. And then we formulate the formula of the volume of the trough. And then it becomes like this. V, the volume, is equals to 1/2 times length times width times height. Length times width times height, and then we find a way that everything here, every variable here becomes only h. So what we do is first we get the width. The width, we divide 0.9 over 1.2. We get 3/4 here, 3/4. In getting the 3/4, we 3/4 times h. That's our width in terms of h. So then we plug everything in. 1/2, because the length has no change. It's only 3.6. There's no change in the length. It's always like that. We leave that as is, which is 3.6. And the width here, 3/4 h. 3/4 h, and then multiplied by h. And then we simplify everything, which becomes everything, the numerator, multiplied everything in the denominator, which is 3.6 times 3h squared over 2 times 4. And if you multiply everything there, you get 27 over 20. Which is just 1.35. And then you place the variable, which is h squared. So this is the v in terms of h. This is our equation now. And then after you do this, you differentiate this equation by differentiating dv over dt, and then 1.35, differentiate this to h in terms of h with respect to time, and that's that. And then after differentiating, because we have the h now, the change of h, then we plug everything in. Our data says that 0.6 is the height of the water, 0.6. So we plug that in, and the change in dv dt is 2 cubic meters per second. So 2 is equal to 1.35, and then 2 times 0.6, the height of the water. So 0.6, 0.6, the height of the water, and then multiply by dh dt. And then we simplify, we clean up. That will become 1.62. We multiplied everything here. From 1.62 dh dt, and then 2. And then you divide, and then you get dh over dt is equal to is equal to 100 over 81, which is just, if you approximate it, it's going to become 1.23 meters per second, cubic meters per second. So that's the change in dH over dt. That's the change of the water rising. That's how fast the water rising is in the triangular trough that we have.